Welcome back, everyone. So, if you've ever looked up at a jagged mountain peak, or stared down into a sweeping river valley, or, hey, even just a rocky hill right near your house and wondered, how on earth did that get there? Well, you are absolutely in the right place. Today's explainer operates on one core, really cool metaphor. The Earth is not just some static, boring rock floating out in space. No way. It is a masterpiece. It's literally a giant planetary art studio, constantly being built up and carved away. Which of course begs the question, right? What invisible forces are actually shaping the Earth beneath your feet? Now, in any art studio, you've got rules. And in our planetary studio, the absolute foundational rules are gradients and gravity. Literally every single movement of Earth material, whether we're talking about bubbling magma deep underground or a massive landslide crashing down a steep cliff, is completely driven by this built-in desire to move from high to low, high pressure to low pressure, high elevation to low elevation. Gravity is the invisible hand guiding the whole shebang.
Okay, let's dive into this. In technical terms, this planetary sculpting is driven by what we call geomorphic processes. Now, I know that sounds like a mouthful, but it's really just a fancy way of describing two things: endogenic, meaning internal, and exogenic, meaning external, forces. These are the forces that physically stress and chemically alter our Earth's surface. They are the ultimate sculptors, fundamentally changing the configuration of our planet.
So to understand exactly how this works, we'll follow a quick roadmap for today's explainer. We'll start with the Earth's hidden sculptors, then look at power from within, move on to the art of weathering, see how gravity takes control, and finally wrap up with erosion and deposition.
Starting right off with Section 1, the Earth's hidden sculptors. Let's look at the two opposing forces in our planetary studio.
You see, there is a literal, constant battle taking place right on our planet's surface. On one side of the ring, you have endogenic processes. These guys are the builders. They're the internal forces actively pushing the clay up onto the sculpting pedestal, basically building up the crust. But on the exact opposite side, we have exogenic processes, and these are the chisels. These are the external elements of nature, things like running water, groundwater, glaciers, the wind, and they are actively working to break all that built-up crust back down.
Moving on to Section 2, power from within. Let's shift our focus to those builders and figure out where the raw material actually comes from.
The energy emanating from deep within the Earth is, frankly, immense. It's the main driving force behind all these endogenic processes. But you might be wondering, what actually fuels it? Well, it's primarily generated by three distinct things: radioactivity, rotational and tidal friction, and primordial heat. Which is just incredible, right? Heat left over from the very origin of the Earth itself. These three sources basically act together like a massive planetary furnace, generating the ridiculous amount of energy required to literally push heavy landmasses upward.
Now, all of this intense energy powers something called diastrophism. You can think of this as the grand umbrella term for all the processes that move, elevate, or build up the Earth's crust. So, the crucial point here is, if the internal furnace is the raw energy, diastrophism is the specific mechanical process that actually lifts our raw sculpting material into place so the outside world can start carving it.
And diastrophism takes four distinct forms, ranging from the incredibly dramatic to the subtly profound. First up, we have orogenic processes. This is hardcore mountain building through severe folding, usually affecting narrow belts of the crust. Then there's erosion processes. Say that 3 times fast. This is the slow, steady uplift or warping of massive parts of the Earth's crust. Third, we have earthquakes, which, relatively speaking, cause minor local movements. And finally, plate tectonics, which is the vast horizontal movement of entire crustal plates over millions of years.
All right, Section 3, the art of weathering. Let's move to the outside forces and see how this sculpture gets carved up.
So all of these external exogenic processes we talked about, they're covered under this fantastic general term, denudation. It literally means to strip off or to uncover. Denudation is ultimately powered by the sun's energy driving our atmosphere, combined with those tectonic gradients we mentioned a minute ago. Together, they act as the ultimate chisels, breaking rocks down in situ, meaning right there on site with very little actual motion, to just slowly, persistently strip away the outer layers.
Now, the actual weathering chisels come in 3 very distinct types. First is chemical weathering. This one relies heavily on things like oxygen, surface water, and soil acids to decompose rocks down at a molecular level. Next up is physical, or mechanical weathering. This depends entirely on applied forces. Think of things like gravitational pressure. the expansion of rock because of crazy temperature changes, or the incredible stress of constant wetting and drying cycles. And finally, we have biological weathering, which is driven entirely by living things.
Now, what's really interesting about this slide is exactly who is doing that biological weathering. We always naturally think of weather and water, right? But earthworms, termites, and rodents, they actually act as tiny, relentless sculptors. By burrowing down and wedging themselves into the earth, they expose completely new rock surfaces to chemical attack. And they open up all these little channels that allow moisture and air to penetrate deep, deep underground.
And sometimes, these weathering processes create absolutely stunning visual features. Exfoliation is a great example. But I want to clarify something here. Exfoliation is a visually striking result of weathering, not a process itself. It's really just the flaking off of curved sheets of rock from a giant bedrock mass. It's what leaves behind those beautiful, smooth, rounded surfaces you so often see when you visit national parks.
So why does all this endless rock breaking actually matter to you and me? Well, weathering doesn't just make dirt. It prepares the way for regolith and soils. Without a deep weathering mantle, we literally wouldn't have the rich forests, the biomes, and the biodiversity we completely rely on. Plus, weathering slowly removes certain materials over time, which actually concentrates the remaining valuable minerals. Without this process, which is known as enrichment, the valuable materials that power our entire modern economy simply wouldn't be concentrated enough for us to economically mine or exploit. It's a real game changer. Which brings us to Section 4. Gravity takes control. Time for the cleanup crew to arrive. All right, so once the rock is weathered down into debris, it needs to go somewhere, right? This brings us to mass movements. This is the transfer of rock debris down slopes under the direct, unyielding influence of gravity. Now here is an absolutely vital distinction to keep in mind. In mass movements, the air, water, or ice does not carry the debris. Actually, scratch that. It's the other way around. The massive weight of the falling debris carries the air, water, or ice with it. And these movements can be anything from a super slow, imperceptible creep to a sudden, catastrophic fall.
Let's look real quickly at the precise mechanics of these relatively dry, rapid landslides. A slump happens when rock debris slips down a slope with a backward rotation. It sort of tilts back into the hill as it falls, like it's leaning backward. A debris slide, on the other hand, is the rapid rolling or sliding of earth debris without that backward rotation. It's tumbling forward. It's all based entirely on how the earth rotates as gravity violently pulls it down.
Finally, we reach Section 5, erosion and deposition, the final stage of our massive geological art project.
It's really highly important to clarify this one point. While weathering certainly aids erosion by breaking massive rocks into smaller, manageable pieces, weathering is not a precondition for erosion to take place. Denudational processes like erosion and transportation are strictly 100% controlled by kinetic energy. As long as an agent, like a rushing river of water, a massive grinding glacier, or heavy sustained wind, has enough kinetic energy, it is going to acquire and transport rock debris, constantly wearing the landscape down.
And this whole transport process happens in two distinct steps. First is erosion, where the agents actually acquire and transport the debris. The second step is deposition, which is really just a natural consequence of erosion. As rivers reach gentler slopes, or as those heavy winds finally die down, these erosional agents lose their velocity. When their kinetic energy drops, they are basically forced to drop their tools, allowing the materials to finally rest and build up brand new landforms somewhere else.
And that brings us to the end of our planetary art tour. As you can see, the Earth is quite literally never finished. It's always under construction and deconstruction. So I want to leave you with this. If you look out your window right now, which of these hidden sculptors is actively carving your local landscape? Are there rivers quietly eroding the hills? Is the freeze-thaw cycle slowly wedging rocks apart right in your own backyard? Keep your eyes open, because the masterpiece is happening right under your feet. Thanks so much for joining me on this explainer, and keep learning.